Number one is about the basic business maths. The basic business maths is going to open the unit for us. Then number two, I'm going to talk about the financial mathematics. Financial mathematics. Number three, we are going to talk about descriptive statistics. Number four, we shall talk about correlation and regression. Analysis. Then number five is the cost, volume, profit, what we call the CVP analysis. The CVP analysis. Then last number six, we shall talk about issues to do with the elasticity. And we will be done. We will be done. So today, we are going to try as much as possible to cover this one and this one. And if time will allow, we shall also focus on the introduction to descriptive statistics. We shall also discuss about the descriptive statistics, but our focus will be this two. But if we can be able to cover this one a bit, so that tomorrow we finish this and this, then day 3, we finish on chapter 5 and 6. So let us start with the basic business maths or basic business mathematics. This is just a reminder of the basic business operations, and for that case, we shall talk about one, the integers, and then two, we shall talk about the fractions on this particular topic, the basic business mathematics. But before that, we need to understand that when we talk about mathematics, we have got 4 basic operations that are normally used in mathematics. The 4 basic operations are A, the addition, B, we have subtraction, 3 or C, we have multiplication, and then lastly B, we have division. These are the 4 basic mathematical operations. These are the basic mathematical operations that are used. The 4 basic mathematical operations that are used worldwide. When we talk about addition, it is the summation, the summation of quantities. When you add some figures or quantities together, you are doing addition. Then when we talk about subtraction, it is the difference between 2 or more numbers. When you subtract or when you less or deduct, you are doing the subtraction. Multiplication, it is actually what we call what? When you multiply. When you multiply, you are trying to do what? Multiplication, like for example, 2 times 2. So in one way or another, you are trying to multiply or to make that figure to go by the same, by a given number, like 4 by 2. It simply means that you do 4 and 4 twice. 4 and 4 twice. So that is multiplication. But then when we have the division, it is when you are sharing a quantity in a given or in a given number. You have, for example, 8. It is being shared by 2. So how many items will each get? That one is the division. That is the division. So under this, we are now supposed to apply them on integers, and we apply these basic mathematical operations on the fractions. How do we do the addition, subtraction, multiplication, and division for integers? How do we do addition, subtraction, multiplication, and division for the fractions? That will give us the basic business mathematics. The basic business mathematics. So I want us to start with the integers. Integers. Under this integers, you write there and note that an integer is any whole number, whether positive or negative. Any whole number that does not contain any decimal or fraction, we normally refer to it as an integer. So, e.g., when you have a number like 9, 10, -6, -5, even 0, all those are known as integers. As long as we don't have any fraction or decimal points, they become your integers. They become your integers. Let me share a document with you on the group that we shall use in our discussion. Check, there is a document that I've shared with you, which can guide us on how to deal with the integers. How to deal with the integers. So we are starting with the first operation on addition of integers. The addition of integers. How do you add integers? So there is question 1 there that is talking about addition of integers, and we are given examples. One of the examples says A, it is positive 2 plus positive 3. And you are told to determine the solution for that. Positive 2 plus positive 3. You need to understand this. Anytime we have got 2 signs, either plus plus or plus minus, that are following each other, you need to reduce them into one sign. You need to reduce them into one sign. And the rules are, when you have positive, positive, the answer, or you can replace this one with one positive. A positive and a positive is a positive. When you have a negative, negative, you can reduce them into positive again. A negative and a negative multiplied by a negative, the answer becomes the positive. When you have negative, positive, you can reduce them using one negative sign. When you have positive, negative, this one can be reduced into one negative sign as well. So anytime there is a positive and a negative, depending, or it doesn't matter which one is coming before the other, negative, positive is negative, positive, negative is negative. But when you have the two of them are the same, plus plus is the same as positive, negative, negative is the same as positive as well. So here we have a plus and a plus. We can have it as positive 2 plus plus, we can replace it with one addition 3. So then what will be the final solution for that? You realize that plus 2 plus 3. If you have already you have 2 items, then you add 3 to the 2 that you have, then the answer should be plus 5. You should be having 5 items. So the key thing is to reduce this sign into one sign. And when we have 2 positive, we can replace with 1 positive. 2 negative, we can replace with 1 positive. Negative positive or positive negative, we replace with the negatives. Okay. Example B that we have there is a case where you have positive 8 plus positive 7. Again, this is positive, positive. It can be written as positive 8 plus 7. When you have 8 items already, and then you add 7 to that, this one is the same as positive 15. That is positive 15. The same case applies to C and D. C says you have positive 12 plus positive 9. Plus and plus is plus, so this is the same as positive 12 plus 9, which is the same as positive 21. The same as positive 21. So you reduce these 2 signs into 1, and then you can be able to evaluate. Let us go to number 2, whereby you are given positive 7 plus negative 4. It is positive 7 plus negative 4. So you can be able to see this now it's a positive and a negative. Right? Positive and a negative, you replace it with 1 negative. It's going to be positive 7 minus 4. Now the question is, you have 4 items, then you subtract or deduct 4 from that. You will find that this one is going to give you what? Positive 3. You are only going to remain with 3 items once you have deducted 4 from 7. This is 2A. 2B, where you are given negative 8 plus positive 5. Rule number 1, 2 signs following each other, you reduce it into 1 sign using this. So this is plus plus is the same as negative 8, plus plus is the same as positive 5. So what will be the answer here? You have negative 8, and then you add 5. So what will be the answer? If, for example, you have already a freezer of 8, but somebody sends you a credit of 5 shillings. How much will be your freezer now? So you realize that this negative 8, once you have received positive 8, positive 5 onto it, it reduces this negative. The negative, if I can go by example, you had a freezer airtime of 8 bob, meaning that you are at negative 8 because you don't have any money. Actually, you are supposed to pay somebody, the Safaricom. Then somebody sends you 5 shillings credit. So you find that your freezer will reduce from negative 8 to negative 3. The answer becomes negative 3. The deficit now will be negative 3. It is not going to be that way. Actually, you can be able to present all this, but we shall do that one later. Let me have another example related to that. 2C, whereby you have 2C talks about what? Positive 15 plus negative 14. This is C. First of all, reduce these 2 signs following each other into 1. It is going to be positive 15. Positive and negative is minus 14. So what will be the answer? This is a case whereby you have let me check. Hey, Mercy, you're not getting me clearly? Am I now audible?
Yes, you are.
Let me check my network. Okay. When you have a positive 15, then you minus 14. It is like you have 15 items, then you subtract 14 from the 15 that you have. You realize that you are going to remain with one. You are going to remain with one item. That is positive 1. Positive 1. What about B? Then I give you the rest to try. B, you have negative 9 plus positive 2. The rule, plus and plus, negative 9, plus and plus is plus 2. So it is another case whereby you have a deficit of 9, and then somebody gives you 2. So the deficit now, you will still have a deficit, but a lesser deficit. You had a deficit of 9, a figure of 9, and then you receive 2 shillings from that. Then you find that you are going to have a negative of 7. The answer becomes a negative of 7. It reduces the negative. So these solutions, or you can get these solutions by using what we call a number line. A number line, it is a line with 2 sides. The neutral point is normally 0. The neutral point is normally 0. To the right, it is normally positive integers. Those are positive integers. To the left, we have the negative integers. That is your number line. So when you are solving this particular expression, it simply means what? You just go to where you have the first integer. The first integer is positive 2. Positive 2 is there. Then we are told plus 3. Plus 3 simply means we move 3 steps towards the positive side because it is positive, right? Towards the positive side. Remember, the positive side is to your right. So from this positive 2, we move 1, 2, 3. We find that we are landing at what? Positive 5. And that is what we have here as our answer. When we have what? This one was positive 12. Positive 12 simply means that we add more positives. This is 6, positive 7, then over, positive 8, positive 9, positive 10, positive 11, positive 12. And then we are told from 12, we go 9. So we are supposed to go from 12, we go 9 steps to the positive side because this is positive. We shall find ourselves landing at positive 21. What about this? You have positive 7 minus 4. You go to where you have your positive 7, the first integer. Then we shall move 4 steps. But these 4 steps from positive 7, we move towards the negative. Remember, the negatives are to the left. So you move 4 steps, 1, 2, 3, 4 to the left. You find that you are landing at positive 3. So when it is negative, you move to the left. When it is positive, you move to the right. This is negative 8. Negative 8 is here. Negative 8 is here. We are moving how many steps? We are moving 5 steps, but to the positive. To the positive, we move to the right. 3, 4, 5. You run that, negative 3. That is your answer there. That is your answer there. So that is how we do the addition of integers using both the normal way and also using the number line. The number line, you just draw the line, and then the neutral point, the point whereby the positives and the negatives are separated, it is normally the 0. 0, it is neither positive nor negative. 0 is just 0. And then to the right, positive, to the left, negatives. That is what it should be understood. Then we can go now to question 2, whereby we are supposed to discuss about subtraction of integers. To subtract integers is like to deduct the integers. Subtraction to subtract integers, you get the difference between them. So the procedure is the same as the addition. Actually, we don't have any big difference between the two. When you have 45 minus 15, this is simply what? 45 minus 15, it's like 45 minus 15, you will get the answer is what? And it is going to be positive, positive back. When the first number is smaller, like for example, you have 17 minus 40, this remember it is positive, 17 minus 40. Obviously, you expect the answer to be negative because we are subtracting a larger figure from a smaller figure. When you deduct a larger figure from a smaller figure, the resulting solution should be negative. The resulting solution should be negative, which is actually negative what? 23. 23. That is not important. Let us go to number 2A, whereby we are given 12 minus negative 7. Negative and negative, we say, will be positive. So we are going to have 12 plus 7. This is the same as positive 12 plus 7 will give you positive 19. Positive 19. What about 3A? Whereby you are given negative 5 minus positive 16. Negative and positive is negative. Negative 5 minus 16. What will be the solution? You are already at negative 5. And then you go another negative 16. You had a freezer of 5. And then you freezer another 16 because it is negative. Negative 5, and then you make another freezer of 16, you will have a negative of 21. You will have a negative of 21. You're already at negative 5. Then you incur another negative 16. It increases the negative. It increases the negative to 21. It increases the negative to 21. What about when we have 4A, whereby we are given negative 15 minus negative 22? First step, two signs should not follow each other. Negative 15, negative and negative is plus 22. So you had a negative of 15, and then now you have received 22. So first of all, we are going to cover the entire negative, and then actually we are going to go to the positive. We are going to go to the positive. Find that we shall now be at positive 7. First of all, we cover, if it was freezer, we will cover all your freezer of 15, and then you have a positive of 7. You have a balance of positive 7 if it was airtight. So that is on subtraction. Subtraction. You see the concept is the same as the addition, only that this is now subtraction. But always, whenever we have the two signs following each other, take them to 1, following the rules that I gave you. Then when we talk about multiplication, the following rules should also be observed. When it is a negative multiplied by another negative, you will get a positive. When it is a positive multiplied by another positive integer, you will still get a positive. But when one of them is negative and the other one is positive, the solution will be negative. Like for example, a negative integer multiplied by a positive integer, you get a negative solution. a positive integer multiplied by a negative integer, you still get a negative solution. Like question 3, whereby you have 2 times negative 6. This is a positive integer multiplying a negative integer, so the answer will be negative. So you do 2 times 6 is going to be negative 12. Negative 12. A positive integer multiplied by a negative integer. Positive 2 times negative 6 gives you the negative. B, that is 1A. 1B, you are given 4 times negative 7. It is another case of positive and negative. We will give you negative. 4 times 7 is 28. It's going to be negative 28. All those, actually the answers will be negative. All those, the answers will be negative because one of them is positive and the other one is negative. All those, the solutions will be negative. But if, for example, you had C, that is negative 4 times negative 3. This is a negative integer multiplied by another negative integer. The solution will be a positive 12. A positive, it is not a must for you to write plus. When you leave it without any sign, it is known that it is a positive integer. What about maybe B, where you have negative 5 times negative 2 times negative 3? We'll try that. What will be there? The sign for the solution. Negative 5, negative 2, negative 3. And you are doing the multiplication or the product. Negative and negative will be positive 10. But positive 10 times negative 3 will be negative 1. Positive and positive is, sorry, negative and negative is positive, but that positive 10 in this case will multiply by this negative 3, then the answer will change back to negative 5. Then if you have, for example, E, negative 9, that is positive 9 times positive 3, we find that this one is going to be positive 27. A positive and a positive, the answer remains to be positive. That is on the multiplication of integers. The multiplication of integers. The last sign now, which is normally the division, the last basic mathematical sign, it is the division. In division, the same concept applies, but now we are doing the division here. Positive divided by negative is positive. Positive divided by positive is positive. Negative divided by positive is negative. And positive divided by negative is going to be negative. The same concept, but now here we use the division. We use the divisions. Like what we have in question number 4. And we are told we divide those. I'm going to be for B, whereby you have 50 divided by negative 25. This is a positive dividing a negative, so the answer will be negative 2. Positive 50 divided by negative. A positive divided by a negative, the solution will be negative. 2A, when you have 288 divided by negative 24, the answer again will be negative. The answer will be negative. 288 divided by 24, negative 24. To get the answer will be negative 12. Negative 12. What about where you have 3C? Giving you negative 40, negative 140 divided by negative 20. This is a negative dividing a negative. Negative divided by a negative, the solution will be positive. We find that this one will be positive 7. That is on the division of integers. Division of integers. You just note the signs of the integers that are being divided. And once you have done the four of them, addition, subtraction, multiplication, and division, you can now go and do what we call the body mass. You can combine them. You can combine them, and that is what we call the order of operations, which involves the body mass. Order of operations. This one entails body mass. It entails body mass. Like, for example, you are given question number 5A, whereby you are given what? 5A, you are given 12 plus 6 divided by 2 minus 34. And you are told to evaluate that. So you cannot just come here and do 12 plus 6 divided by 2 minus 34. If you do that, you get a very wrong answer. You need to make use of the body mass. First of all, deal with the bracket if it is there. Of, it follows, and of is the same as multiplication. Then if it is not there, you go to division. After division, you do multiplication, addition, and then subtraction comes last. So in this case, we don't have brackets, we don't have of, but we have division. So the division is this part here. Positive 6 divided by positive 3. So the answer will be 12. Positive 6 divided by positive 2, it is going to give us positive 3, and then minus 34. We don't have multiplication, but we have addition. That is 12 plus 3. You'll get this one is going to be 15 minus 34. Then now you can do the last bit. 15 minus 34. You get your answer will be negative 19. And this is the correct answer. Otherwise, if you just do it the way it is, you just say 12 plus 6. Let us do it here. 12 plus 6 divided by 2 minus 34. You'll get a different answer, negative 25. So anytime we have got more than 2 signs in an expression, apply body mass. This is what will give you the right answer. That is what will give you the right answer. Part B of number 5, where we have 24 divided by 3 plus 5 plus 4, times 5 minus 8 divided by 4 times 10 plus 1. And you are told you work out that. So you need to look at the body mass and identify what should be done first. We have division. Division is there, then division is also there. Remember the sign, either plus or minus, belongs to the integer that is ahead. Like for example, this 8 is attached to this negative. So when we are dividing, we must take note of this negative. This negative is for 8. It belongs to 8. So here we shall do 24 divided by 3 is 8 plus 4 times 5. Then you do negative 8 divided by 4. And negative divided by a positive, the answer is negative 2 times 10 plus 1. We are doing the division. Then we go to the multiplication, whereby we have this part here and this part here. So we are going to have 8 plus, because 8 is not yet, we have not yet had addition. 8 plus 4 times 5 is 20, minus negative 2 times 10 is another negative 20 plus 1. So I have dealt with this. 4 times 5 is 20, negative 2 times 10 is negative 20, then plus 1. At that point, now you have 2 options. You can take those that are positive to be together. I can decide 8 is positive, positive 20 is positive, and positive 1. They are all positive, and then negative 20, I put it aside. Then 20. 8 plus 20 plus 1 will be 29 minus 20. So the answer will be 9. The answer will be 9. So you do it procedurally without skipping anything. You do the division, you get the answers for the division. Negative 2 and 4. Then you do multiplication. 4 times 5, negative 2 times 10. You get the solution. Then at that point, because you are now having the plus and the minus, you can put all those with positives together, all those with the negatives together, and then you get the difference later on. Let me do E, and then you try the others. E. E says you have 56. Then this 56 is divided by 14 times 6 minus 3 minus 9 plus 3. You are told you evaluate that. So what do? Oldman says what? Division to become fast here. So 56 divided by 14. You get the answer is 4. You work out this, you get 4 times 6 minus 3 minus 9 plus 3. Then we have multiplication this part. 4 times 6 is 24. The others will remain the way they are. Then from there, we can put the positives together and the negatives together. So that we have 24 is positive and the positive 3. Then negative 3 and the negative 9 like that. So that if I do the addition here, we get 27. Negative 3 and the negative 9, both of them combined, they are negative 12. If you are at negative 3 and then you get another negative 9, you go down to negative 12. So this one will give you what? Positive 15. That is all about the integers. That is all about the integers. Any question? Any question? Before we go briefly to the fractions, then we do something else. This is just the reminder. That's why it is known as the basic mathematics. Basics. Now we can do the fractions. The fractions. So a fraction is a number that is written in form of A over B. Any number that is written in form of A over B is known as a fraction. Where A, the number that is at the top, is known as the numerator. And the number that is below is known as the denominator. The number on top is known as the numerator, and the number below is known as the denominator. We have got different types of fractions. We have proper fractions. This is part A. This is a fraction where the numerator is smaller than the denominator. The number that is at the top is smaller than the number that is below. So e.g., you can have 1 over 2. 1 is smaller than 2. You can have 3 over 5. You can have 7 over 13. You can even have 10 over maybe 17. Such kind of fractions, as long as the numerator is smaller than the denominator, those fractions we normally refer to them as proper fractions. Then that is A. B, they are the fractions known as the improper fractions. Improper fractions. These are fractions in which the numerator is larger than the denominator. Like for example, 29 over 7, 16 over maybe 3, have like 20 over, for example, 7, such kind of cases or such kind of fractions, they are regarded as improper. The numerator is bigger than the denominator. Then we have got C, what we refer as the mixed numbers. The mixed numbers. These are a proper fraction with an integer. A fraction that comprises of an integer and a proper fraction. E.g., you have like 2 and 3 over 5, 7 and 5 over 8, 15 and, for example, 13 over 20. Those are known as mixed number. There is an integer here and a proper fraction. An integer and a proper fraction. These are known as the mixed numbers. So under fractions, again, we are going to look at how do we do the addition, subtraction, multiplication, and the division. So the first rule, that has combined the addition and subtraction because they are very much similar. For addition and subtraction, we shall start with A, the fractions will give same denominator. Fractions with the same denominator. So, like for example, you have like 2 over 5 plus, like for example, 6 but 1 over 5. The denominators are the same, 5. So whenever you have got fractions with the same denominators and you are adding them or subtracting, what you do, the answer, the denominator will still be the same as the denominator that were on those fractions that were being added or subtracted. It was 2 over 5 and 1 over 5. So the denominator in each case is 5. Even the answer, the denominator will be 5. Then what you do, you just add the numerators. 2 plus 1, you get it is 3. And that is the solution. So if you have got 4 over 7 plus 2 over 7, the answer will also be over 7. 7. But now the numerator you add the numerators of each fraction, you get the answer is what? 6 over 7. If you have 4 over 15 plus, like for example, 6 over 15, your answer will be over 15. Then you add this to 10 over 15. A case whereby the denominators are the same. You just take one of the denominator, it is going to be the denominator of the solution, and then you just add the numerator. If it was subtraction, like for example, 6 over 11 minus 2 over 11, the answer will still be over 11. Then you minus the numerators. 6 minus 2 is going to be 4. If you have got 13 over 17 minus 5 over 17, the answer will be over 17. Then you minus, this one will get what? 8 over 17. That is basic. When the numerators are the same, the answer will have the same denominator. When the denominators are the same, the answer will have the same denominator. And then either you add the numerators or you subtract the numerators depending on the sign that is in that particular expression. The second case is the case where the numerators are not the same. A case where the numerators are not, the denominators are not the same. Like for example, you have 1 over 5 plus maybe 2 over 3. The denominators are not the same. In that case, you need to determine the LCM. you need to get the numerator will be, the denominator, sorry, will be the LCM of this denominator. The LCM, I hope you can remember, we needed to do it like this. Like, for example, it is 5 and 3. We used to do it the rough method. We find that we don't have a common term that can divide 5 and 3. We don't have a number that can divide 5 and at the same time divide 3. So we take the smaller number, which is 3. This one will be 5. 3 divided by 3 is 1. You take 5. 5 will divide 5 to be what? 1. And here we have 1. Then you multiply whatever you have here. 3 times 5 becomes the LCM, which is what? 15. So the answer here will be over 15. That is the LCM. Then what you do, the LCM is 15. So what do you think you are going to do? You take this 15 divided by 5. You take the LCM, you divide by the denominator of it. So 15 divided by 5 is 3. 3 times 1 is going to be 3. 15 divided by 3 is 5. 5 times 2 is 10. So the answer will be 3 plus 10 is 13 over 15. 15 divided by 5 is 3 times 1 is 3. 15 divided by 3 is 5. 5 times 2, 10. So you add that, you get the answer is what? 13 over 15. If you are at a point whereby you can do this, can you try this for B? When you have 4 over 7 plus 2 over maybe 5. What will be the answer? Can you try that for me? So first of all, you get the LCM. The LCM of 7 and 5 it is the same as 5 times 7 because no number can divide these two. The LCM will simply be that 5. That 5 divided by 7 is 5. 5 times 4 is 20. That 5 divided by 5 is going to be what? That 5 divided by 5 is 7. 7 times 2 is 14. So this one will be equal to 34 over 35. The same case applies when it is a minus. See, you have what? 3 over 8 minus, for example, 5 over a figure like what? 6. You are told you get that. The LCM of 8 and 6. 2 can divide both of them to get 4 and 3. 2 can divide 4 to get 2 and 3. 2 can divide these 2 to get 1, 3. And then now you multiply by 3. 3 divided by 3 will be what? Now 1, 1. So the LCM will be 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. The answer will be what? This is 8 times 3, 24. So the LCM in this case will be 24. 24 divided by 8 is 3. 3 times 3 is 9. 24 divided by 6 is 4. 4 times 5 is 20. So the answer will be what? Negative 11 over 24. That will be the resulting answer. In some cases, you can be told to get or to add a mixed number with another mixed number or a mixed number to a fraction. Like for example, when you are dealing with mixed numbers. When you are dealing with mixed numbers, you must convert them. You must convert them into a proper fraction. Like for example, when you are told to do 3 over 5 plus 2 and 1 over 2. These 2 and 2 and the 1 over 2 can be converted into an improper fraction. To convert it, you take the integer, you multiply with the denominator, then you add the numerator. So this one can be the same as 3 over 5 plus 2 times 2 is 5. 5 plus 1 is 6. So you do 6 over 2, 6 over the denominator. When it is like that, it is an improper fraction because the numerator is higher or bigger than the denominator. Then from there now you can go this procedure. You follow this procedure. The LCM of 5 and 2 will be of 10. 5 over 2, the LCM is 10. 10 divided by 5 is 2. 2 times 3 is 6. Plus 10 divided by 2 is 5. 5 times 6 is 30. So the answer will be 36 over 10, which you can be able to convert it back into a mixed number. No? How many times can 10 go to 36? It's going to be 3. Because that is 3 whole number. And then once we multiply 10 by 3, it is 30, meaning that the remainder will be 6. What I've done here, you can do a normal division. 36 divided by 10. 3 times 10 is 30. So what is the remainder? 6. So the solution will be 3 whole number and then 3, which is the remainder, over the divisor, which is 10. That is the working solution. So anytime you are adding or subtracting a mixed number, you need to convert it first of all into an improper fraction. Like for example, you have 2 and 1 over 5 plus 1 and 1 over 4. First of all, convert them into mixed number. This is the same as 2 times 5, 10. 10 plus 1 is 11 over 5 plus 1 times 4 is 5. 5 plus 1 is 6 over 4. Then you can get the LCM of 5 and 4 will be equal to 20. Then you get 20 divided by 5, 4. 4 times 11, 44. Plus 20 divided by 4, 5. 5 times 6, but this is going to be 74 over 20. Then you can do your division here. If you have 74 being divided by 20, you will agree with me, it's going to go 3 times because of 60. We have a remainder of what? 40. So the answer here would be the solution up there. 3 whole number and then over and 14 over 20. The remainder right over the divisor. That is the solution. That is the solution for us. Addition and subtraction of fractions. When it goes to the multiplication, it is even easier because with the multiplication, you multiply the numerators, you get the answer of the numerators. You multiply the denominators, you get the answer of the denominator. And then that is all. But for the mixed numbers, first of all, convert them into mixed numbers. So if you have, for example, 2 over 3 times 1 over 4, what you do 2 times 1, which is 2. 3 times 4, 12. That is the answer, which you can simplify into 1 over 6. If you have like 5 over 13 times maybe 3 over 4, you simply take 5 times 3 is 15 over 3 times 4, that is 652. Like that. But when you have 3 and 1 over 5 times 4 and 2 over 3, first of all, you change them into proper fractions before you multiply. You take 3 times 5, 15. 15 plus 1, 16 over 5. Times 4 and 2 over 3. 4 times 3, 12. 12 plus 2, 14 over 3. Then you can go ahead now and multiply 16 times 14. You get 224 divided by 2. Then you can change that into proper fraction. Nothing more for division. Nothing more for division. If they are either improper or proper fractions, multiply the numerators to get the solution of the numerator, multiply the denominators to get the solution for the denominator. This one can be converted back into a mixed number. We get it is going to be actually 14 and 14 over 15. If you go the wrong procedure, you get that. Allow me now to take it to the last operation, which is division. Division of integers. Not integers, but fractions. For the division, like for example, you have 5 over, let me say 8, divided by 3 over maybe 7. For you to be able to do that division, you will take the first fraction, which is 5 over 8, and multiply with the reciprocal of the second. The reciprocal simply means what was the numerator becomes the denominator, and the denominator becomes the numerator. The two values will interchange. Instead of 3 over 7, it becomes 7 over 3. So now you can do a normal multiplication. You take this times this, you get that 5 over 8 times 3 is 24. And then you convert it back into a mixed number. If you have 9 over maybe 13, divide by maybe 5 over 11, you take the first fraction the way it is. Then you multiply, but when you replace the division and the multiplication, these ones will change. The numerator becomes the denominator becomes the numerator, times 11 over 5. You find that this one is going to be equal to 99 divided by 65. And you are done. For the mixed numbers, first of all, express them into improper fractions. Like for example, if you are told 1 and 1 over 3 divided by 2 and 4 over 5, we'll first of all convert this one into proper. Then say 1 times 3 is 3, 3 plus 1 is 4 over 3, divided by 2 times 5 is 10, 10 plus 4 is 14 over 5. Then now you apply this approach. This is 4 over 3 times 5 over 14. And then you find that this one is going to be equal to 20. 4 times 5 is 20. Divided by, this is 30 plus 12 is 42. So I want you to follow the questions that I've given you for fractions. Try to solve them. You'll get your answers right if you follow that procedure. So that is all about the basic mathematical operations. We have seen how we do the addition, subtraction, multiplication, division of integers, and also the addition, subtraction, multiplication, and division of fractions. After we have done that, now we can move to the next area, which is financial mathematics. Financial mathematics. This is mathematics that is related to money matters, financial mathematics. So here, our main focus will be on interest. The interest, it is the amount of money when you borrow or when you invest, you are going to get or to pay on top of what you borrowed or invested. So if I have borrowed a loan of 100,000 shillings, and then after repayment, I find that I have paid a total of 120,000, and I had borrowed 100,000. The 20,000 which is on top of the 100,000 that I have borrowed, is the interest. And what you borrow or what you invest, we normally call it the principal. The principal is what you have invested or borrowed, the original amount that you borrow or invest. Then, when you invest, obviously your money will be earning interest. So if you make a savings of maybe 100,000 in a fixed deposit account for maybe 2 years without any withdrawal, after 2 years, that amount will not be the same as the 100,000 that you had deposited. You will get something more. So the extra amount that you get in your account on top of what you had deposited is what we call interest. So that is what we are going to discuss majorly here. And on that note, therefore, when we talk about interest, we have got two types of interest. We have got two types of interest. A is what we refer as the simple interest. B is what we refer as the compound interest. We have got the simple interest and the compound interest. We start our discussion by looking at the simple interest. We have said that the amount that you borrow or invest in a business or in an account is known as the principal amount. Is known as the principal amount. So, the principal amount, this is amount you borrow or invest. So when we talk about the simple interest, it is the interest that is only earned on the principal amount. The interest that is earned only on the principal amount. The interest that you earn in year one, in year two, that interest that is not earn interest. The interest will only be calculated on the principal. Let us have an example. You have deposited shillings 150,000 in a fixed deposit account. That is simple interest of what? 10% per annum. And then you have done this for the period. The money will be in the savings will be maybe 3 years. So how much will be your simple interest? At the end of the 3 years, how much will be your simple interest? So you find that in year one, your interest, your interest will be equal to the principal, which is 150,000, times the rate of earning the interest, 10% times 1 year, because we are only considering the interest for year one. From the beginning to the end of year one, that is 1 year. So you find that usually will be equivalent to what? Earn an interest of 15,000. We go to year two. The interest will simply be 150,000 times 10 over 100 times another 1 year, which will give you another 15,000. In year three, the interest will still be the same 150,000 times 10% times another 1 year, 15,000. So the total interest that you earn will be equal to what? 15 plus 15 plus 15. This is 45,000. This is the total interest. And therefore, if you are asked how much will be in this account at the end of year three, what you get in your account at the end of year three, that is now what we call the amount, is normally given by the principal plus the interest. What you find in your account is the 150,000 that you deposited there, plus the interest that has been earned of 5,000, you get 195,000 shillings. Or that is the amount that you are going to withdraw after the third year. But the most important thing about the simple interest, the interest that is earned here is normally constant, because it is only earned on the principal, and the principal amount does not change. So the interest itself, it does not change. To make it more simpler, when you are told it is 3 years, it is simple interest. To get your interest, You simply take the principal amount, which is 150,000. You multiply by the rate, which is 10%. You multiply by the duration in years, which is 3. You find that this is 15,000 times 3, which will give you 45,000, which is the same as the 45,000 that we got. So here I was doing it year by year so that you can be able to see that the interest does not change when it is simple interest, because it is only calculated on the principal amount, and this principal amount is going to be a constant figure. The interest also will be constant per year. Good. We can have another illustration. Maybe Tom borrowed, maybe let us put it simple, 100,000. Borrowed 100,000 shillings. And then at the end of the year, after 4 years, the amount that was due, the person was supposed to pay was related to 130,000. Paid or cleared the loan with 130,000. Now you are told find the rate of interest if it was under simple interest. Find the rate of interest if it was under simple interest. Here we have got the amount. Remember, we are told Tom borrowed 100,000, but after 4 years, he repaid the loan in 130. And the bank from where he borrowed the loan charges a simple interest. But now we are told what is the percentage rate of simple interest. So you need to actually play around with what you are given and what we are trying to find out. So if you are given the amount and you are given the principal, using this equation, remember we said amount is principal plus interest. In this case, we are given amount and principal. We are able to determine the interest. Because we know, therefore, the amount that was used to clear the loan is 130,000. Should be equal to the principal that was borrowed, 100,000 plus.
Mama will help you to put it 12. Please, Laji. That's dangerous. Okay? That's dangerous. Mommy will help you. Okay, son?
Okay, let's continue. The principal, the amount that was used to clear the loan, and we have the principal, which is the amount that was borrowed. Then, in simple terms, we are not given the interest, but this expression can give us the interest. So if we take 130,000 that we used to clear the loan, we minus what we had borrowed, you will find that we are going to find the interest was what? 30,000. First of all, we paid an interest of 30,000. How do we calculate the interest? And interest, when it is simple, it is the principal times rate. The rate is normally in percentage times the time. In this case, we have the interest. We have computed the interest, which is 30,000, times the principal, which is 100. Sorry, will be equal to the principal, which is 100,000, times the rate, which we don't know, times the time. It took 4 years to clear that loan. So you can be able to get this and this, this and this. We are going to get that 1,000 equals to this is 1,000 times 4, which is 4,000. 4,000 times R will be 4,000 R. Hope you got what I've done there. 0, 0, 0, 0 will remain with 1,000. 1,000 times 4 is 4,000. 4,000 times R is 4,000 R. So 30,000 divided by 4,000 will give us 100. So 30 divided by 4, we get 7.5. The rate of interest that was charged by the bank is 7.5% per annum. 7.5% per annum. That is on the simple interest basis. So you can play around. First of all, you need to understand two very crucial formulas. One is the formula for getting the simple interest. In simple interest is given by the principal times the rate, which is over 100 or percentage times the time. The second very crucial formula for you to understand is this one. The amount, the total amount that you are going to get or to pay. It is going to be the summation of the principal and the interest. Once you have those two formulas, you can be able to play around and get any figure that is not provided. Be it the amount, be it the principal, be it the interest, be it the rate, and even the time you can be able to get the moment you have these two formulas well understood with you. When they are well understood with you. Then we can proceed to the next type of interest known as the compound interest. The compound interest. When it is a compound interest, it simply means that the interest that is earned in the prior years will also earn interest in the subsequent years. If, for example, you have invested your money for 3 years, in year 1, we are going to calculate the interest. That interest that is going to be earned in year 1 will also earn interest in year 2 and year 3. The interest that is earned in year 2 will earn interest in year 3. And then the interest in year 3 will not earn, because that is the point whereby now we are going to withdraw a total amount. Let us go back to our initial example, whereby we deposit shillings 150,000. The time, 3 years. The rate is 10%. If this amount was being compounded, then this is how, or this is the amount of money that will be the account of that person. In year 1, the person will earn an interest of what? 150,000 times 10% times 1 year. I'm doing it yearly. So this one is equal to 15,000. In year 2, first of all, you calculate now the new principal. The new principal, the amount that will be in the account. Remember, you deposited 150. After 1 year, 15,000 interest has been earned. So that 15,000 is supposed to be added to the principal amount, which will be 150,000 plus 15,000. Already your account has grown up to what? 165,000. So for year 2, the interest will be equal to what? The principal now is 165. Even the interest in year 1, it is now going to earn interest. That's why it has increased 165. So you take 165,000, you multiply by 10%, and another 1 year, you get this one is going to be 16,500. So when you go now to year 3, the principal will change. In year 2, the principal was 165. 65,000. Now we have added another interest of 16,500. It was 165,000 plus 16,500. You get 181,500. So when we calculate the interest for year 3, it's going to be principal, which is 181,500, times the rate, which is 10%, does not change, times another 1 year, which is equal to 18,150. So the total amount, the total principal or amount that will be there will be equal to what? In year 3, we started with 181,500. In that year, we have added 18,150. So how much will be in your account? Plus 18,150. The account will have 199,650. So unlike the simple interest whereby the principal remains constant, we use 150,000 every year as the principal. Under the compound, the principal amount will keep increasing because the interest in the prior years are added to the principal to get the principal that will be used to calculate the interest in the subsequent years. So even the interest is earning interest. That's why you find that the amount here is more. Remember, under the simple interest, the total amount was 150,000 plus 45,000, it was 195. Under simple interest, the total amount after 3 years was 195. But here now it is 199,650. Why is it more? Because here, even the interest in the prior years were used to calculate interest in the subsequent years. That is the common. And then you'll agree with me, if you had done a savings, for example, 20 years, to go this from year 1, year 2, year 3, you calculate it like that up to year 20, it might be a bit tiresome. When you go to year up to the last year, if the years are many, it might be a very long process. To make this work a bit simpler, we have what we call the compound interest formula. We have got a formula we call compound interest. With the compound interest formula, it states that amount after a certain number of years is given by the principal, that is the starting amount, in bracket 1 plus r percent raised to power n, where P is the principal amount, N is the number of years, R is the compound rate of interest. Like in this case, our P is 150,000, our R is 10%, our N is 3 years because we did this up to year 3. So what will be the amount? How much do you expect if you invest 150,000 at 10% per annum compound interest for 3 years? Therefore, the amount will be equal to 150,000 into bracket 1 plus 10% raised to power 3. So you get this one to be 150,000 into 1 plus 10 over 100 is the same as 0.1 raised to power 3, which will be equal to 150,000 times 1 plus 0.1 is going to be 1.1 raised to power 3. Then you can use your calculator to do 1.1 raised to power 3. This one will be 150,000 times what? 1.1 raised to power 3. You get 1.331 times 150,000. You get 199,650. What we got there? Huh? What we got there? So that is the compound interest formula. The compound interest formula. The N is normally in years. The R is normally in percentage. The P is the amount of money that you started. If it was a loan, the principal amount that you borrowed. If it is a saving or investment, the principal amount that you started as your investment. Let me give you another illustration. Give you another illustration. Maybe a businessman borrowed 80,000 shillings. That is what was borrowed. Then he's supposed to pay back that particular loan after maybe 4 years. And then the compound rate of interest is 12%. So now the question is, how much will the businessman pay to clear that loan? How much will the businessman pay to clear that loan if it is under the compound interest? Remember, this person will pay the principal amount that he borrowed plus the interest, but this interest is being compounded. It is not simple. So you come here and say, the amount that will be payable will be equal to 80,000, which is the principal, into 1 plus the rate in percentage raised to the number of years it will take before repayment. So this one will be equal to what? 80,000 times into bracket 1 plus 12% is the same as what? This is going to be 0.12 raised to the power 4. This is the same as 80,000 times 1.12 raised to the power 4. So in 4 decimal places, you get is going to be 80,000 times 1.5735. 4 decimals. It is good we put them in 4 decimals to avoid a lot of rounding of errors. So this one will be equal to what? 1.5735 times 80,000. We get 125,880. That is the amount of money that will be paid to clear the loan. So the interest in this case, the amount of interest, you get the amount minus the principal. The amount that we have cleared the loan with is 125,880 minus 80,000 that was borrowed. Get the interest payable here is 45,880. That is the interest that we are paying on top of the principal. On top of the principal. That is it about the compound. So the compound interest, the interest per annum is not constant. It keeps increasing because the principal amount also keeps increasing, since the interest for the previous years is added to get the principal to be used in the subsequent years. Having said that, I want us to look at the last area. The last area on this financial mathematics, which is called the intra-year compounding. Intra-year compounding. The compounding that we have done so far, it is normally done at the end of the year. So we do compounding only once a year. After 12 months, it is per annum. But we have such cases whereby the compound interest is calculated somewhere in between the year, before the year comes to an end. Before the year comes to an end. So if the compound interest is calculated before the year comes to an end, then it is known as the intra-year compounding. It's known as the intra-year compounding. So under that cases, you can find that compounding is done semi-annually. Compounding can be done quarterly, or it can be done monthly. Those are the most commonly used types of intra-year compounding. So instead of waiting up to the end of the year, or instead of doing compounding once in a year, under semi-annually, here we do 2 times. Do it at the middle of the year and at the end of the year, semi-annually. After 6 months, we do the compounding. Quarterly, we do 4 times. 4 times means every 3 months. After every quarter, a quarter in a year is normally 3 months. After 3 months, we calculate the compound interest. After another 3 months, we calculate the compound interest. So in 1 year, we have done 4 times compounding. Then monthly, this is when we do 12 times in a year. 12 times in a year. 12 times in a year. When it is under the intra-year compounding, the formula for getting the amount at the end of the period is given by P into 1 plus R, which is in fact R actually, R over M percent power N times M. Power M times M. This is the formula, where M is the number of times compounding is done in a year. The number of times compounding is done in a year. So which can either be 2 times when it is annually, 4 times when it is quarterly, 12 when it is like that. So if it is semi-annually, amount will be obtained by doing P into 1 plus R. Our M here is now going to be 2 because we are doing compounding twice in a year. And then N we multiply by 2. The number of years we multiply by 2. If it was 2 years, we will do compounding. If it is 2 years, remember in 1 year we do twice. So in 2 years we can do 2 times 2, which is 4 times. 4 times. If it is quarterly, our M is 4. So amount will be equal to P into 1 plus the rate we divide by 4. And don't forget it should remain to the percentage. And then the N we multiply by 4. You divide by 4, you multiply by 4. You divide by 2, you multiply by 2. If it is monthly, amount will be equal to P into 1 plus R over 12% power N times 12. You divide the rate by 12, you multiply the N by 12. That is it. Let us have an illustration here before I give you a question. On your retirement, you receive a pension of, let's just say, 500,000 on retirement. And then you are considering saving this amount in a fixed deposit account with the following options. One, it is an account that pays annual interest of 10% for 3 years. You want to save this money for 3 years. B, it is an account that pays does semi-annual compounding, or let us use 12% in all cases, of 12%, an annual compounding of 12% per annum of 12%, that will be enough. Yes, let it be per annum. Number C, it is quarterly. You want to save in an account that compounds quarterly. Quarterly compounding at 12% per annum. This one is 3 years also. This one is 3 years. And lastly, B, monthly compounding. At 12% per annum, 3 years. Then you are told to determine the amount that will be received under each of those schemes. So for annual compounding, we use the initial formula. Amount is going to be the principal. It is 500,000 that we received as pension into 1 plus 12% power 3. Here we don't divide by M and we don't multiply by M because it is annual. When it is per annum, we use the compound interest formula the way it is. That is for annual. So we get that amount. For B, when it is semi-annually, we shall take amount to be equal to 500,000 into 1 plus 12. We shall divide it by 2 when it is semi-annually, and then it was 3, we also multiply by 2. This rate we divide by 2, the time we multiply by 2. So this is the same as 500,000 into 1, this is percentage, plus 6%, 12 divided by 2, 6%, power 6. You work out that. You divide the rate by 2, you multiply the time by 2. The rate was 12 divided by 2, 6%. The time is 3 times 3, 6. When it is quarterly, amount will be equal to 500,000 into 1 plus 12, you divide by 4, then power 3 times 4. So this one will be equal to 500,000 into 1 plus 12 divided by 4 is 3%. Then we raise it by 12. When it is monthly bid, you do amount will be equal to 500,000 into 1 plus, the rate is 12%, divided by 12, because monthly we shall do it 12 times, percent, power 3 times 12. Power 3 times 12. So what we get is going to be equal to 500,000 into 1 plus 12 divided by 12 will be 1%, power 3 times 12, which will be 36. That is what we mean by intra-year compounding. Intra-year compounding. You are supposed to solve and get the answers for each of that. And then you can be able to tell which one is giving the highest yield. The one that is giving the highest amount is the scheme that will advise that particular retiree to invest in. So I want you to finish that. And on top of that, on that document that I shared with you, there is a question that is appearing as the last question. I also want you to try that. So when we meet tomorrow, we shall do the descriptive statistics and see what else we can do. So tomorrow is another day. Any question before we end the class? Any question? Did the class rep manage to join? Class rep, are you in the midst?